Hello students, in the previous video we have discussed about two types of chemical reaction, that is combination reaction and decomposition reaction. Now in this video we will discuss about displacement reactions and double displacement reaction. Now what is a displacement reaction? Displacement reactions are those reactions in which one element displaces the another element from its compound or from its salt solution. Means when a more reactive element displaces a less reactive element from its salt solution is known as a displacement reaction. As you can see that in the general way we can represent it like this, where A is more reactive element and we have a compound BC in which A is replacing B and we are getting AC and B is separated out. So here A is replacing B. So this is an ideal example, ideal representation of a displacement reaction in which a more reactive element, we can say, displaces a less reactive element from its salt solution. Let us have an example that when a zinc metal is placed in copper sulphate solution, zinc displaces copper from its salt solution and we are getting zinc sulphate and copper. You can see that here zinc, it is replacing copper and we are getting copper in separate form and zinc is occupying the copper's place. So this symbolizes that zinc is more reactive than copper. In this reaction, zinc displaces copper from copper sulphate compound so that copper is free. This displacement reaction takes place because zinc is more reactive than copper. This should we keep in mind, that zinc is more reactive than copper. Then how do we come to know that that an element is more reactive than the other? It is done with the help of an reactivity series. It is done with the help of reactivity series. Now what is a reactivity series? It is a series of elements in which the elements are arranged in the decreasing order of their reactivity from top to bottom. This is a series in which we have kept elements in the decreasing order of their reactivity. Means the elements which is more reactive is placed at the top and the element which is least reactive is placed at the bottom. And the least reactive element cannot displace a more reactive element, or we can say a more reactive element displaces a least reactive element. So most reactive elements, they are generally kept at the top. You can see that these are the most reactive elements and they are placed at the top, and the least reactive elements, they are placed at the bottom. So this is the most reactive element. We are having potassium, which is most reactive element, and at the end we are having gold and platinum, which are the least reactive elements. So upper metals can displace lower metal from its salt solution. This you should keep in mind, that upper metal displaces lower metal from its salt solution. Now we are having here, we can see that when a piece of iron metal is placed in copper sulphate solution, we are having a copper sulphate solution which is blue in color, and we are putting an iron nail in it. We can see in the previous slide that iron is more reactive than copper. We can see that iron is more reactive than copper because iron is placed above copper. So iron can easily displace copper from its salt solution. We can see that iron is displacing copper and ferrous sulfate is formed and copper is in the free form. And you can see that the color of the solution changes. We can see that the blue color of the solution turns to green and a brown coating of copper deposit on the iron nail. So this displacement reaction takes place because iron is more reactive than copper. If iron is more reactive, then only it can displace copper. Now a question arises, what happens when copper reacts with zinc sulphate? Now this is a reaction in which copper is reacting with zinc sulphate. Now again we should look at the reactivity series in which we can see that copper is lying below zinc. You can see here that copper is lying below and zinc is lying above. So can copper displace zinc? No, copper cannot displace zinc. So the reaction could not take place. The reaction is not possible. The reaction will not take place because copper is less reactive than zinc. Hence, copper cannot displace zinc. So therefore, the reaction does not take place. So for doing this displacement reaction, you have to memorize, you have to learn the table, that how these elements are arranged. For that, you have to do this table. And you should keep in mind that upper metal can displace the lower metal, but lower metal cannot displace the metals which are present at the top of the reactivity series. Now we should look at another type of reaction, that is the double displacement reaction. Double displacement reaction means in which the two reactants or the two compounds, they react by the exchange of ions. This is important, in which we can see that the two reactant molecule, they are exchanging their ions. For example, there is an exchange of ions between C and D. That means you can see that A is having D and B is having C initially, but when they react, the exchange of ion takes place, and now this A is having C and B is having D. So you can see that there is a flipping of ions, that there is an exchange of ions between the two compounds. So the two new compounds are formed, and hence it is known as a double displacement reaction. So those reactions in which two compounds react by an exchange of ions to form two new compounds are called double displacement reaction. Now look at an example. When barium chloride reacts with sodium sulphate, first of all we prepare an aqueous solution of barium chloride. Aqueous means that simply we add salt, barium chloride to distilled water in one test tube, and in another test tube we add sodium sulphate. We prepare aqueous solution of both the salts. Now when we add barium chloride solution to sodium sulphate, what do we observe? We observe that barium sulphate and sodium chloride is formed. And one important characteristic of this reaction is that we obtain a white precipitate of barium sulphate. As I already told you in the previous video, that when we have a precipitate formation, we represent it by a downward arrow. So you can see that a white precipitate of barium sulphate is formed. Any reaction in which an insoluble solid called precipitate is formed is known as a precipitation reaction. So many times in board exam it is asked that what is the other name of double displacement reaction. So double displacement reaction is also known as precipitation reaction. So here we are having the two aqueous solutions of those salts, and when we are adding, we are obtaining a white precipitate of barium sulphate. So you have to memorize the color of the precipitate also, because sometime it may be asked in the board exam that what happens when barium chlorides react with sodium sulphate, what is the color of the precipitate so formed. Yeah, it may be asked that what is the other name of this reaction. So you will write that the other name of this reaction is precipitation reaction. Now we can look at another example of this double displacement reaction is reaction between lead nitrate and potassium iodide. So the reaction between lead nitrate and potassium iodide is also an example of double displacement reaction or precipitation reaction, in which a yellow precipitate of lead iodide is formed. So when lead nitrate reacts with potassium iodide, we obtain lead iodide and potassium nitrate, and the color of the precipitate is yellow. So we are having here yellow precipitate of lead iodide. Now look at this activity. We are having a potassium iodide aqueous solution. We are preparing an aqueous solution of potassium iodide, and when we add a drop of lead nitrate to it, you can see here that a yellow precipitate is formed. You can see that the yellow precipitate of lead iodide is formed. So this is a beautiful example of double displacement reaction. Hope you like this video. If you have any query, any problem, then you can do in the comment box. Please like and subscribe my channel. In the next video, we will discuss about redox reactions and examples of oxidation reaction in daily life. Thank you.